Okay, guys, let's go ahead and talk about what's going to be on your test tomorrow. First thing is the property of acids. We need to know all the properties of acids, meaning that they taste sour, they conduct electricity, meaning they're strong or weak electrolytes. If they're strong electrolytes, that means they're a very strong acid. If they're a weak electrolyte, that means they're a very weak acid. And remember that strength of acids depend on how much they ionize. A very strong acid will ionize completely. A very weak acid will only ionize partially. Now, they react with metals to form hydrogen gas, and they change indicators, meaning blue litmus paper, to red. Acids are red. And remember, they react with hydroxides, meaning hydroxides are bases. So acids react with bases to form salt and water. It's called the neutralization reaction. Now, properties of bases. They react with acids to form water and salt. They taste very bitter. They feel slippery. They can be strong or weak electrolytes. Strong acids or strong bases are strong electrolytes. And they turn red litmus paper blue. Bases are blue. Now, strong acids and bases. Strong acids and bases ionize completely in water. Weak acids and bases do not ionize completely in water. Okay? Strong acids, strong bases ionize completely. Now, the way we measure acidity and being basic, we do that with the pH scale. Specifically, the pH stands for the percent of hydronium or hydrogen ions in a solution. pH tells us if the solution is acidic or basic. We already said that. And we use the pH scale. Okay, anything below 7 is considered acidic. Everything above 7 is considered basic. And 7 is neutral. Okay, again, remember that pH is the percent of hydrogen ions. We use our pH scale. We can see that the acids are going to be red and bases are blue. Now, our acid-base theories that we need to know. The first one is the Arrhenius definition of an acid and base, which acids produce hydrogen ions in an aqueous solution, and bases produce hydroxide ions when dissolved in water or in an aqueous solution. The main point about Arrhenius definition is that it's in an aqueous solution. Remember that hydrogens or acids give hydrogens, bases give hydroxides. The next definition is the Bronsted-Lowry definition, and that's the main definition that we've used in class to determine if something is an acid or a base. Remember that acids donate protons. They donate that hydrogen ions, and bases accept protons or accept that hydrogen ion. Okay, with Bronsted-Lowry, we also get the definition of a conjugate acid and a conjugate base. Now, a conjugate base is what is left over after an acid gets rid of a hydrogen, and a conjugate acid is a product that gains the hydrogen from the original acid. Remember that acids produce conjugate bases, and bases produce conjugate acids. Now, we can see examples of this on this page. What we see is that we have our acid and our base. So we have our acid and our base. We know that because we're looking at the hydrogens. The water gave up a hydrogen, the ammonia took a hydrogen. Okay, so anything that accepts a hydrogen is a base. Anything that donates a hydrogen is an acid. And we see that acids make conjugate bases and bases make conjugate acids. And we see the same thing with hydrochloric acid and water. Okay, the hydrochloric acid gives up that hydrogen. We see chlorine's all by itself now. The water accepted it, so acids make conjugate bases, bases make conjugate acids. Now, the last theory is the Lewis acid-base theory, which that is the broadest of all the definitions of acids. And we know that a Lewis acid is an electron pair acceptor and a Lewis base is an electron paired donor. Way you can think of this is it's kind of opposite of the Bronson-Lowry definition. Bronson-Lowry acid donates a hydrogen, while Lewis acid accepts an electron. Okay, Lewis bases donate an electron. Bronson-Lowry base accepts a proton or accepts a hydrogen. Okay, remember that's the broadest of all the three definitions. We talked a little bit earlier about neutralization reaction. What that is, it's an acid plus base equals water plus salt. Every single time we put an acid base together, we get water and salt. Okay, this is just restating it and giving us some chemical equations. We see we have an acid and a base. We know that because the hydrogen is the very first element in HCl, and we know that sodium hydroxide is a base because it has an OH at the end of it. Anything that starts with a hydrogen is an acid. Anything that ends with an OH is a base. So we have an acid base together. It creates salt, and meaning NaCl and water. Same thing here with sulfuric acid and potassium hydroxide. We have that hydrogen, we have that OH, so we have acid base. We make salt and water. All right, guys, let's go over a few problems. First one, we have a reaction. We have H2SO4, and we're reacting that with water. And what we see it produces a hydronium ion, and it produces a hydrogen sulfate ion. Okay, so what we see have happened in a question on the test, what you want to be able to do is you want to be able to label what's an acid, what's a base, and what's the conjugate acid, what's the conjugate base. Now, with H2SO4, telltale sign, we know that it's an acid. It starts with hydrogen. Well, we also see that water starts with hydrogen, but in this case, if they both start with hydrogen and one of them's water, take the other one. So we know that H2SO4 is going to be an acid just by looking at that hydrogen. We also know it's going to be an acid because we look at the other side and we see that it went from 2 hydrogens to 1 hydrogen. So that means it donated a hydrogen ion, which is a proton. So therefore, anything that donates a hydrogen is an acid. And we look at water, and we know that it is a base because it accepted that hydrogen. It went from 2 to 3, so this is a base. So we know that acids make conjugate bases, and bases make conjugate acids.